welcome to another video. Here is a question on density and pressure. If 1.0 cubic meters of concrete weighs 5.0 times 10 raised to the power of 4 Newton. So we have, what is the height of the tallest cylindrical concrete pillar that will not collapse under its own weight? The compression strength, which measures the maximum pressure that can be exerted on the base of the structure, is given to be 1.7 times 10 raised to the power of 7 Pascal. So now, this is how to solve this question. Now, first thing first, okay, let's write down the given value. So we're giving the weight of the concrete, and that is given to be 5.0 times 10 raised to the power of 4 Newton. Then we're also given the volume of the concrete, which is V. That is given to be 1.0 cubic meters. Okay. Then we're also given the pressure, which is the compression strength. That's P. That is given to be 1.7 times 10 raised to the power of 7 Pascal. Now we want to calculate the height H. Now we know that weight is the force exerted on a body, okay, due to gravity. And that's what we have here. So the material, the concrete, weighs 5.0 times 10 raised to the power of 4 Newton, okay? So which means we can also measure the pressure, which we know to be the force acting per unit cross-sectional area of a material. So it can also be weight per unit area. Weight per unit area, that's pressure. So that means P will be equals to W over what? Area. Now, but we know that volume, okay, is equals to area times height. So what is area from here? Area is volume over what? Height. Area is volume over height. That is when we make area the subject of the formula. So we are going to have V over H to be the what? Area. So we can substitute V over H for A in this formula for pressure. So we know that pressure equals to weight divided by V over what? Over H. And we were given the volume, okay? The value of V is what? 1.0 cubic meters. The value of W is what? 5.0 times 10 raised to the power of 4. Then also we are given the pressure, so which means it will be easy for us to what? To get the value of H using this formula. Now let's write it in standard form. This will be P equals to WH over what? Over V. And we want to find H. So let's express H in terms of what? In terms of V and others. So that will be PV over what? W. So the height of the tallest cylindrical concrete pillar that will not collapse under its own weight has a formula H equals to PV over what? W. That is according to this question. Because there are other cases, like when we are looking at some questions, on what we call strength of material, there are a lot of formulas that will come up that will make us, that will now lead us to on to how will be able to derive the formula for height H. Okay, all right. Now in this case we have H equals to PV over what? W. So let's plug in the values. So H will be equals to the pressure, which is 1.7 times 10 raised to the power of 7, multiplied by the volume, which is 1.0, okay, divided by the weight, which is 5.0 times 10 raised to the power of 4. So let's not forget that the unit of H will be what? Meters. So what is 1.7 divided by 5? Because 1.7 times 1 is same as what? 1.7. So 1.7 divided by 5, that will be 0.34. So H equals to 0.34 multiplied by 10 raised to the power of 7 over what? 10 raised to the power of 4. then this will be h equals to 3.4 times 10 raised to the power of negative 1 multiplied by 10 raised to the power of 7 minus 4. Then the unit again is what? Meters. So that h will be equals to 3.4 times 10 raised to the power of negative 1 plus 3. Yeah, because 7 minus 4, that's 3. Okay, so minus 1 plus 3, that will be 2. So that h will be equals to 3.4 times 100. Okay, then the value of h, which is the height of the tallest cylindrical concrete pillar that will not collapse under its own weight, will be 340 meters. And this is the height of the tallest cylindrical concrete pillar that will not collapse under its own weight. The noblest pleasure is the joy of understanding. Bye bye.